Okay. Where did people get the ice cream from? I missed it. All right. Good afternoon. My name is David Ennis. I'm going to give you a little walkthrough on fun with PHP and big data and various databases. It's sort of a loaded thing. I changed the presentation as I went on after I talked to quite a few people about what their needs were with PHP. So we're going to start with a fancy PowerPoint presentation, which I hate. So that's the end of the presentation. All right. Well, I do all my notes in MindDump software, free mind and things like that. And so I was trying to figure out how I was going to get this tree into PowerPoint, and then I just said, forget it. And I dumped the MindDump into one file and made it somewhat pretty with CSS and left it at that. But yeah, my boss hates me at work. He asks me questions on this and things like that, and I can't do it, so it's gone. Okay, so I'm going to start right now with a few things. If I can see how bad my CSS is. Actually worked. Start with who I am. My name's David Ennis. I'm originally from Boston. Lived back and forth between Ireland and the U.S. for years. Lived in California in San Jose for a couple of years. Worked as a webmaster of the Tech Museum of Innovation when I was there. Have two kids, one wife. We know I'm from Boston. I have two passports, which is sort of nice, but a little freaky when you try to prove where you've been. Like when I tried to rent a car in the U.S. and they asked about my license in the U.S. and they said, prove that you've been out of the country for 2 years. I have no stamps in either passport. It's a bit bizarre. I live in The Hague now. I lived in Leiden for a couple of years and switched to The Hague right by Land van Nuys India Station, so I can get anywhere in the country in no time at all. It's very convenient. I like museums. I sort of grew up in museums, Museum of Science in Boston, Tech Museum in California. That's where a lot of my background started, which was nice. You know I hate PowerPoint, and the last thing I didn't put is I'm addicted to fizzy water. My record for turning in bottles, which you get 25-cent deposit, is €7 in a week. So I drink a lot of fizzy water. That's enough about me. We'll move on to the next bit. Okay, a couple things. Don't blink. This is an overview talk, and I've packed in what I should have done in 3 hours, and I tried to trim it out, but it's not going to happen. Actually, I'm going to do one thing before I forget. I have a little timer on the top. I always put in things so I remember up there in the corner. So I need to remember where I am. Basically, using MySQL for the samples, I chose a relational database. I chose the one I've been using from the start. I'm not saying one thing or another about MySQL or Postgres or anything like that, but I chose the one that I know. Makes a bit of sense. And in here, there's a lot of stuff I know from years of using it, but I spend about a third of my time between systems administration, a third of the time with pretty much MySQL, and a third of the time PHP. I like that split. It means that I know about the other technologies, so it helps with the other one. So spent about 3 years only doing MySQL and about 3 years only doing PHP, but now I'm set across all of that. So along with everything, I manage about 11 servers across the board. So in here, databases are changing all the time. Some of you are specialists in certain databases. I'm not going to cover what you know in this, one, because I don't know it all, and two, because it's an overview. So grumble at the end and tell me what I've said wrong. It's fine. Let's see. I'm going to show you one link based on that little conversation now. I like this display, this picture that's going to come up if I have the internet, or it's going to stay blank. Yeah, an article I found just showing the roadmap of databases and how quickly it's changing. In this case here, this guy had to redo this December, January, and February because it was changing so quickly. So that's basically sitting here. By the time we were done talking, some new database has shown up with some new feature that people like, and it'll be the next hot thing. So we're not going to cover it all, and by the time this talk is over, it's going to be old. So. On my computer right now, most of the samples I'm using, all the samples I'm using are actually local. So on my local databases, turned off caching for MySQL. Doesn't help disk cache, so some of the results, once I do a few things, the disk cache will come in handy. It will come in. And most of the commands I'm using SQL no cache, so I'm trying to keep it as accurate as possible, being just raw queries. I actually put this little bit of information in here because it occurred to me when I was talking to people last week about local databases versus service-oriented databases. And I just put it in here. I never thought about the fact that you sort of had to, or data stores, not necessarily databases. And people may always be looking at something they can install on their computer when there might be a service-based thing that would work fine for what they need. That's there. And the last one, before we ask the next question, but how many of you, with what you're using databases for now, say you're using relational database, how many of you actually have the resources and infrastructure, time, and energy to redo what you're doing, to switch to something that's new? I'm glad there's a few. There's always some. But the point is that things can change quickly, but you can't change as fast as the next thing you're seeing. That's a reality, and that's what made me tune this presentation a little bit differently than I originally thought, because that's the case. It's great to talk about what's here, but if you can't use it, it's only so good. People using relational database, how many use a relational database in their work? Okay, that's what I thought. How many have tables that they actively use, not archive tables or anything like that, with more than 1 million records? More than 3 million records? Okay, so numbers change very quickly. But even for relational database, unless you're looking at something really complicated, it's really not that much. So it was funny trying to figure out what to do in here, and we talk about big data, and well, the answer to that for PHP in a lot of cases is use the API for something else. But we're going to work through and start with how you can get more out of what you're already using, because you can't switch, or at least you can, but the rest of the room can't. So moving forward in here, one of the questions is, if you think about whether you can switch or what you're doing, does your data change often? Do you need to manage it? That's a really important one when you talk about other options that are out there. Do you need to analyze it? What are you using it for? There's a lot of solutions out there that you can analyze stuff that doesn't change or doesn't change it often a lot faster than data that you have to manage. Part of it is because you use heavy indexing or something. You can't switch it as quickly as you need to manage it. And do you actually need something that's transaction safe? So those are lots of questions to talk about what you could or couldn't do with choices that are out there. And there's another one I put in here is the data that you have is easy to parse and do something with. And these questions come from the fact that I don't just do web applications. I often end up taking big data dumps from other things and using them for other purposes or analyzing data. So all of what I use it for isn't PHP web applications. And this is where it comes in. These questions come in. Is that I don't always put stuff into a database. If I'm doing certain things with it, I might access it directly, and I might get a big dump from a company I need to analyze the following week, write some programs, including some sort of caching on the functions, let it run crazy for the weekend with seeding all the caches, and then get the answer. So it's not always that I end up putting stuff in a database. You can actually manage lots of data through other ways. So that's why I asked these, do you actually need it in a database? Not always, and I'm going to show that in one of the samples. This is more about things about mostly my relational database, but I'm going to put these in here on the fact that most of you in this room can't change what you're doing. We'll talk about different things that you can do to get more out of your database, and I've kept these fairly straightforward. Look up the rest on your own or ask. We're going to fly through a lot. So they're just tips and tricks with PHP. We see a lot of things where people loop through records, get them back, do some math, loop through, insert. This is a medium level talk, so that shouldn't be necessarily the case with all of you, but you see it all the time, or you see it in code that you've taken over. There's a lot of manual work done in PHP that's not necessarily needed that the database can do. And one of the things, a little tip that I use is that I'll often need to update a whole bunch of records, and I'll actually maybe create a temporary table with tens of thousands of records, and then issue an update command with a join on the temporary table. It's a little trick. It can speed up a lot of the work in getting updates to a whole bunch of records. There's lots of different things that make it faster in doing that approach, and depends on your data, but in some cases, instead of running through and doing an update on 7,000 records, insert 7,000 pieces of information with a key and what you're updating, and then issue a single update command on the join on that, and that can speed things up for you. Tune the database for your needs, and InnoDB tuning and MySQL. There's a lot of places I go and I look at their MySQL systems, and the first thing I do is I run top a few things to see what's happening with their database, and I see that MySQL is using 6% of the memory on the computer, or 2% of the memory on the computer, and it's running InnoDB, and you go and you look and realize that there's absolutely no caching at all on InnoDB, for instance, because when you quickly look online, you say tune MySQL, you don't see that right away. So if you're running a MySQL database, then you've got lots of data, lots of queries going on, lots of joins, and maybe lots of views, and your database isn't using your memory, something's probably wrong. So that's the first thing, is actually make sure that your database is using memory. If it isn't, you're probably not using a lot of the features in the database that's needed. That one, everyone should know, get content back in chunks, lots of different ways. Don't get it all back. Use stored functions. I use this a lot as well. Or stored procedures in MySQL for update. Now in MySQL you can actually update data as well. You used to not. That shows how old I am, that I didn't realize at one point that they had switched. So you can do quite a bit with stored procedures in MySQL and other databases. So use them when you can. Get away from PHP at times that you can. This is a big one. Nested selects. You see select for the parent, get the children, et cetera, and selecting. You see someone doing a loop and selecting, and they're basically walking the database down. There's plenty of other solutions out there, and I don't think I'm going to go into it, but just look up nested set models. Beautiful samples. Some frameworks already use it. CakePHP used it even in their alpha version, and when nothing else worked, that actually worked. Another thing that we often do is we create a queuing system. So run processes offline, and basically either in a table or in separate tables. Use to run a processor, give it a unique ID, insert it into a table that says insert. Basically, you're inserting where the queue field is empty, and so you can actually claim a whole bunch of records, process, and keep going. And if you need to, in this case here, you can run more processes to process more of your data. These are all little tricks that are just pretty much right off MySQL. Use views, people should know that. And another one that I see a lot is people selecting data back to find out, or selecting to see if something is there. And there's many cases that you can use on duplicate key update. So you don't have to select something in order to then find out if it's there. We're going to fly through the rest of these. Use a framework that works. If you have a framework that has relationships, make sure you're not querying back a lot more than you need. So the frameworks with when your databases have grown over the years, start to crumble when you realize under the hood they're doing a lot of joins for stuff you don't need. The same thing, a lot of them instantiate objects that when they're created, they actually have constructors that create a lot more queries. So there's times where you only need part of the database, part of the data back. Don't instantiate objects if you have the choice in your framework, and you don't need it. Proper indexing is a big one, and I don't know, describing your select statements. I always do that when I'm doing something new to find out what's actually happening under the hood with it. And I put this one in here, consult the right docs. And there's a lot of people that I work with that use PHP, and a lot of the samples I get are from PHP.net, which is great. But then if you look at the samples that are at PHP.net for some of the MySQL stuff or whatever, you'll find that some of them are almost 10 years old, 7, 8 years old. So they're great samples, but in all fairness, a lot of the people who put stuff down there, they're outdated by almost a decade. So I say that because you're using PHP, but you want to manipulate a database. Go to the manuals for the database and the help for the database and find out actually how to do it, and not what someone that did PHP, because you're writing PHP often to use SQL to manipulate the database. So start at the docs that are actually written for the database, and you can get a lot further, a lot faster. So I said earlier, I don't always access data directly or through a database. I had to find a way to get some big amounts of data on my laptop that will actually show some useful stuff. And I decided for that I used the shuttle radar topology, SRTM data from the space shuttle about a decade ago. It went and mapped a lot of the world, a big stripe through the center of the world, skipping the water because it's all pretty much the same level. This data, I chose it because it'll fit on my laptop, and it has lots of records, and it just seemed like a good thing that I could quickly bloat and use as some samples, and they're real samples too. So direct access to data, that's one of the things I said I would cover. I didn't actually put a huge in here about sharding, but there are times, again, when I take big amounts of data and I need to analyze it or find some stuff in it, and I don't need to actually put it into a database. And so one of the options that you have is sharding it. And you can even do this with just a for each loop in a single process, or you can create little objects, which I usually do, where you manipulate the pointer. So if you want to find something in there and you've got a 20 gig file and you need to find some little code and someone gave you a weird dump, and it looks like, so you get this big giant dump and it's huge and you need to find some bit of information in here. Well, there are no line breaks or anything like that in here. What I often do with stuff like this is I will actually I will basically put the cursor systematically in different places. If I put 100 little processors going and have it walk through there with a little window looking for what I'm looking for. So look up sharding online. It's a good little thing. You can do it in a loop or nested loop. You can basically, all you're doing is manipulating the cursor. You move it, position 1, start scanning for a certain amount. Also then move it down to position 10,023 or whatever it is and keep scanning. And you do that in process. So like pseudo-parallel scanning of the file. You can actually make huge differences in finding stuff. It is possible that it's the last place in the file and it's not going to be any faster at that point. You can't make it faster. But it's possible, instead of starting at the beginning and going right through a file, basically start essentially in 100 places or 1,000 places and scan forward until you find what you're looking for. And it's not just extracting one little bit. You can also use that if you're looking for, say, a big giant JSON thing or whatever. Once you find what you're looking for, you pattern match and work backwards until you find a whole object or something and extract it. So you can do quite a bit of that. I'm also, again, not always putting stuff in databases, so that's what some of these samples are. But we're actually going to go to some real-world examples now. All right. Okay, I use this also, again, a disclaimer. If you have data that's changing all the time, some of the stuff in here doesn't make sense because a lot of it has to do with caching or whatever. I took all the SRTM files for Europe. There's 1,200 rows and 1,200 columns in each. There's actually 1,201 each direction because of an overlap of one column. That's 1,044. The math is there. There's 5,800 tiles that make up essentially across Europe. And that doesn't include water. They don't even include them. And so that is, well, that's a lot. So the point is that you can have big data in this respect, which is a lot of records. So I now essentially have, though, if I needed to analyze part of the height information anywhere in Europe, I can do it from my laptop. In some ways, very easily. I can certainly create graphics. I can stitch together a whole bunch of them, and I can do quite a bit without ever getting into a laptop or into a database. So we talked about each tile, et cetera, et cetera. Now the nice thing is that it's easy to deal with. 16-bit signed int. It's very easy to grab the data. It's also predictable in file size. Every file is the exact same size. This is the idea of how the data is stored in there. Basically, 1,200 rows and 1,200 columns. You can manipulate and find from one row to another column by simply the offset of 1201, and it gets you to the next row. So you can actually isolate and find a smaller section in there just by knowing how many places how many positions to position your pointer in the file. So you can actually extract smaller bits too by adding 1,201 as many times as you need to get down in the file. So this is what the information looks like in these files. And every file has I think, did I even put that on here? Oh yeah, every file is named with the southwest corner of the file. So I know that I've got north 53, east 007. Well, north 53, I think is too high for the. I don't know if it. North 48, east 03, or something like that. That's somewhere in I think southern France. So basically, the nice thing is that the file name itself actually is your key to a section of the data. So if you know that you can write a simple program that says I need to get stuff from this point to this point by the simple math of floor, it can actually find what file name it needs, or file name. So I can actually just, with that, I could get a set of files I need and rattle through them. And if I wanted a smaller section because I needed bigger files, and it's just offsets of 1201 until you find it. So basically, simple math, I could select a whole bunch of tiles. What you end up with is a little program. For instance, a real world example. So I actually go. I still found a link to the original raw data that's here that was just accessed through FTP, and I grabbed them, and I was waiting for guys in a helicopter and all dressed in black to come over to my house when I sat there and churned away overnight on the computer. It's the same link that I had from about 5 years ago that was still there. So these are all the files. It only takes 16 gig for all of Europe, so we're not talking about big in that way, but still, I think it was whatever billions of points. So now if you could easily take a little bit of math and find out what files you needed to get an image that you were trying to make. Okay, so in here I've just a little simple program that I wanted to analyze one of these and actually see what was in there. And basically, in this case, I'm describing one of them, and I've got a tiny bit of a. I flew through that, didn't I? Yeah, that wasn't very good. Basically, it's I create a little color ramp, and in this case, I'm only using 2 colors to make it simple. A little color ramp so I can color based on height, and I go through and I get all of the images. I'm not doing anything funny here. I'm actually creating an image that's 1201 by 1201, so I'm not even having to do math in this case for translating that down to an X factor to actually scale it. So I've got an image that's exactly as wide as the pixels in the sample. But again, it's little math to do that, so it doesn't matter. And then I rattle through it, and I simply color it based on the little scale that I have. And then I do a tiny bit of fun stuff. There I actually do a little tiny bit of shading, fake hill shading by darkening it if all the pixels in one direction are higher or all the looks. And then another thing I do is give it some fake water where I turn around and I say, most things that are flat are water. In my quick sample. So I look at every point and I see if everything around me is also the same level. Roughly, I think I do it every 6 out. It must be water, and I color it blue. So that's it. And so in this simple here, well, I've got a few files in here. Let's see. So in this case, it's already gone through and created the image, and I stop here as far as getting bigger, but it doesn't take much more to have grabbed more tiles and extracted more information. It doesn't take any longer, and about a third of this is generating my color map, and I'm not quite sure what it's because it's image create to color, and GD, I think, actually takes longer than scanning the entire file. Okay, oh, well, that's not a very impressive place on Earth. Well, I guess if you live there it is, but it's not doing it for me. Let's see what the other one was. I must have brought something else in. 43 East 07. Oh, yes, this is 43 East 07, 43. It's going to be in the Mediterranean. So we'll do this one here. Oh, by the way, I like maps. I didn't put that on the list. I forgot about that one. Okay, so this is one tile. It could be many tiles, but from extracting the data from 1.4 million records, analyzing it, shading it with a little bit of math, and creating the image, again, which takes as much, we okay, so this was taken. This is the entire thing just pulled out. But again, you could have taken in a smaller section, and the shading is just a little bit of math in there. But that's just to show that sometimes you don't need to go into a database to manage lots of data. I actually use this in real situations where I do grab and tile and do overlays based on that height information from the entire set of data. I do it for real life for some of the stuff in the States. But again, that's a lot of data to manage or analyze without a database, and only because it's so organized. But in this case here, if I actually needed to find out where places were above a certain height, it doesn't do me any good. I actually have to go through every one of them. So there's some, in this case here, it's good for this purpose, but it's not good for actually analyzing the data, for scanning through and finding all the height from it. I think I got everything that's in here. But just to show you some of the things that I was doing this morning to look at, that's Lake Como stretched out. That's Le Havre in France. And I hope you all bought your swimming trunks because that's where we are. That's what NASA thinks of where you are right now. Somewhere I think you're somewhere right about here. So I thought that was an interesting one to see when I went through analyzing the data. So it worries me every Monday, the first Monday of the month when I hear the flood sirens testing. It still reminds me that I should not be anywhere that you have to drive uphill to get to the beach. It's a little freaky. No, it takes about a while when you realize that you've been here long enough that you actually do that, and it's really weird. There's no such thing as seeing the beach in the horizon. You see it creeps up on you because you're like at the bottom of a swimming pool. I'm moving on quickly, and I probably didn't even say it. The SRTM data, but let's look at something people actually have in real life. You've got XML files. In this case here, again, I posted online a few weeks ago. I've got pretty huge XML files that I use for some companies. They change them about once a week. I don't put them in a database. They might even change some of the fields. I know the fields I need. So in this case, the same thing. I've got some PHP scripts that I have all these get such and such by such and such, and I rattle through and get all the results. And I actually have a little caching function that I put at the top, and I seed this thing for the first day when I get it, and basically walk through the data. And in that case, I don't actually put it into a database. But that gets really, really ridiculous at sometimes. So I'm not even going to give the sample of how to do this. It's pretty straightforward. The only thing I would add that anyone else would have is that I always cache it, and I when I use it, I cache the stuff and then seed the cache overnight or something, so then it's ready to go. But I'm not going to go anywhere with this because there's nothing more to add except for the caching. But let's just say I've got these same files that change once in a while. I only care about a few fields that are in there. Actually, I could better talk about these two very quickly. I put them under direct access locally. SQLite and Berkeley Database. Don't underestimate other things you already have on your computer to deal with stuff. And these are both here, and I put them both on here. They have different uses. SQLite now claims that it deals with much larger things, but it's still a single file system. I use this. Another thing with GIS stuff is to find out all the impossible situations in Europe on road networks. You have roads or places where there are 2 roads going in or 2 roads going out. So you can't get there. And so the way we deal with that, to analyze that, of analyzing actually flat ASCII files of all the segments that connect all the nodes across Europe, is actually with 3 bindings to just key value stores with the Berkeley database. And we simply count how many things go into a node, how many things go out, and how many things go both ways. And just one pass through to do the count on 3 different files, and then after we go back through and find out which ones don't match. So it's very fast for doing that type of work without actually having to get into anything major. We're going to fly through the next little bit now, and we've got some samples that were all about not using the database. Let's use the database itself. So here we go. I have imported into my database wow. Okay, now this is where we get to the point where you say you can't change away from MySQL or whatever relational database you're using or whatever, but you have to make it do better than it's doing now. And I've talked about tuning already, which people sort of ignore. Here, what I have, I've taken a whole bunch of the files in here, and I've got the corner, which is actually the name of the file from earlier. I have the row and the column, which is really just scanning through the entire thing, and I have the height, the other information. So I've put all of this in here, and I've got okay. Someone put the commas in the right place on that and tell me what that is. That's 167 million records in this MySQL table. And again, it's small, but it's still in there. And I didn't do all of Europe. You know why? Because I have indexes on here, and I set it going overnight, and I woke up the next morning, it was still going. So this is the trade-off. If I have to change this data, this is not necessarily the right route, but if I don't have to change it, it's a good way to go. So now we talked earlier, my attempt earlier, I couldn't actually change the data. And again, these are just to show you, I'm trying to think of some way to get a lot of data, something that's not going to work with a simple select statement. Not that I expect that this is the data you have, but you have data that's grown over the years, and you wonder why every year it's getting slower and slower. The same queries worked 2 years ago. Well, when you find out that your one session table or something like that suddenly has 112 million records because somehow it was an InnoDB table and it was never purging because it got so big at some point that it failed on the locks and couldn't purge. That's an actual real thing that happens with InnoDB if it gets too big in a single table. It'll actually time out before it actually deals with the lock to delete the data, so it grows indefinitely. So in this case here, I've got 167 million records in a MySQL database. I imported it. It's nothing special on this one here. And if I try to select something back from that, that's the XML one. I'm at 27 minutes. Christ almighty. I try to select that data back with no cache. I'm not even going to do the first two because we'll just sit here. And I'm already out of time. But I will do is take one of these other ones. And this is about knowing your data and knowing what it's used for. If I do the select back with any type of fancy stuff on this, it'll just churn. It's just simply that. That's what will happen. But if I paste in this, which is a different table, and I want to get, let's see, I'll get, that's not even a big one. Still, I'm selecting data about 4 of those, and okay, I got back some millions of records in 1.83 seconds. When I try these things with the original table, it can be up to 24 minutes. And I'll explain why the difference is. It's the same data, same select statement, different table. So there I can actually find some information like that that doesn't seem overly useful. But if I look at some of the other samples here, I want to find all the places, another simple sample, all the places where there's a height of 1 across all of the data that I have in there. Again, you can't do it with the data when it's in the directly in the database with a standard table. But here we go. From big 1. Again, we're not going to try that one. Okay, this one here, it's not doing a lot, but I just did something that was really fancy and it worked fine. That's because I'm looking at the data differently. Before I was looking at specific field called corner. In this case, I really care about height. So I'm still not there. That doesn't quite do it for me. But if I use another table with the same data, big. I'll try 3. Okay, now I'm going to do the same thing. Height of 12, all the fields of the 167 million records, and how many of those exist in each tile that meets that criteria. Sorry? Yes, thank you. Okay, 0.55 seconds. 62 of the tiles that I have in there have that, and that got me back 267 million records. So again, out of the 160-something million, 267,000 records. And let's just change the numbers again. So there's 60. So these are basically showing you that knowing what your data is, knowing how to store it and how to manipulate it means a lot. So the same data, I couldn't manage it all. In MySQL, same table, same create statement, except for one line that's different. And that's the partitioning. It's there's lots of different options. And again, look at MySQL to find out the differences. That's the partitioning options that you have. In this case here, I've partitioned differently in 2 different ways. Partition one time with a hash on the corner field and another one on the height. So in this case, look up the partitioning. Same data, not manageable with the direct insert with a standard create statement. And then in this case here, all I've done is done some different partitioning, and it's 1 extra line. In this case here, 1 extra line. It's not the greatest partitioning, and it doesn't actually make a lot of sense what I've done there because I could have used sub-partitioning and done it differently. But the point is, you can get a lot more out of MySQL if you actually start manipulating and using the database itself more like it wants to be used. So I think that's a big increase, 0.62 seconds over 25 minutes. And that's basically what's happening with that one. Now again, I've got the next type of situation where I've got this sample XML that's extracted into different tables. And in that case here, same type of situation where I've got Okay, I have my XML. Okay, in this here, I've got I think about 1 million records in XML that's of XML. Okay, whoa. That's why I have copy and paste on the other screen. That was useless. Okay, but regardless, there it goes. You saw it go by. Oh, for God's sake, man. It's still bad. Okay, but regardless, I've got about 1 million records in here, and if I try to do, I'm going to go right back through my my history instead of doing. No, I'm not, because look how it looks. So these XML records, I want to use XPATH to take a value out of the XML records that are there. In that case, for XPATH, I have straightforward. I want to return the name of a field and using XPath to find it from my millions of records split over lots of different records. And in that case, Christ Almighty, is that being recorded? Same thing. We're not going to stay here for that long for this. Millions of records, trying to run XPath queries across it is not going to happen for us. Okay, so does anyone understand what I'm saying here? It's using XPath within MySQL to analyze XML packets that are stored in the database. I do that. It works what I need sometimes. But in this case, you're still running through every record and running XPath on it, so you haven't actually done anything better than being in the files. But if we manipulate that by adding to it, I'm going to skip the middle one and go to the very last one. And add to it a little bit of magic ahead of time. I got back a record in 0.4 seconds from my million records, and still using XPath. And that's actually because in this case here, I know my data. It's XML. It's pretty much easy to scan and look at. And I've tuned this database, MySQL, to use a full-text search with different stop words to make it nice and fast. So what I've actually done is I've told MySQL to find things that look like what I'm looking for, give a much smaller subset, okay? Give a much smaller subset, and actually from there, then use XPath. So I'm using the database to get a lot more out of it. Now I've been told I have 5 minutes, but according to my little watch thing, I should have 7 or 8. Okay, so we're actually very quickly running out of time. So I'm going to show you one of the other options. The other things is that this doesn't work for people. So the next thing you're going to do is move it into different tables. We're going to fly through this. Extracting to separate tables. We all know where that's going to go in the relational database. It's going to go through lots of joins, and over time you're going to get with what I end up dealing with, which is I'm not even going to go there. This is the schema for a CMS that I use. It's big, so that's what happens. So you then put caching on it. I don't think I'm going to get the entire solution here, but one of the options is then to turn this into here we go. NoSQL database here. And someone here would turn around and say, okay, use NoSQL, NoSQL, whatever. And yeah, I go into MongoDB with this. Who has time to learn it, change your data, get into it, learn a different API? I wanted to get a sample here where I could actually do something in very quickly. Acaba server is a fairly new server that's out there. It's document storage. The nice thing is that I can take this and create, dump out my information from MySQL tables over and over, and insert it right into a document store and start querying with REST. And I'm going to, in my 2 minutes that I have left, okay, I have Sample.SQL. It's create tables. I've got joinings in there that these to join them together. I have and I have some data that I'm going to put in. So I'm going to okay. What's happening here? I'm actually using Postgres PSQL to interface with a different server, which is off. I'm going to run out of time before I get to this part. Basically, in this case here, the Acaba server allows you to use your relational database tables in Acaba from MySQL, store them in there, and manipulate them through NoSQL, through REST. And they've added one more really neat thing, which is that they actually have you can actually use MySQL mirroring to keep a copy in the other server. So you can actually start testing on a NoSQL type solution with your data as it is in MySQL. So sort of start replacing it. So in this case here, was my 2 minutes that are left. I'm out of time. All right. In this case here, I actually just created this. I'm going to do this one last sample. I didn't clean the data up before it went in, so I've got some errors in there. But in this case here, if I this is a little tiny PHP script. All right, I just fucked it up. I did just mess it up. That's what I get for going too fast. Basically, at this point, the data's already in there. I don't know what I just did. Sorry. Thank you. Okay, so this record actually came back through a Postgres interface, into a NoSQL database, from a NoSQL database, with data imported directly, exported out of MySQL with a create statement with a small change, and then imported again. Acaba has the ability online actually for you to use a REST interface they have, but it's all open source and you can edit it yourself. The reason I was going to show this is simply because it's a way to start testing with your existing data. So just look up Acaba. I'm not plugging it or anything like that, but I found it very quickly. Within 1 hour, I had exported my data from looking at the docs, imported it, and was running NoSQL and REST tests against it. So you can use it for your existing stuff. That was a fly-through on that. And the last thing is, with my 1 minute that I have left, is to go over some of the other options that are here. I put Mark Logic in here. I'm going to go through this list. So first of all, don't underestimate Solr. I use Solr a lot for lots of different things. Go online, and you might be using it in the background of something you don't know already. Of course, one of the first things I used it for was on top of MongoDB to get some stuff done. I put Mark Logic in here, but actually the it's a closed source system, and it used to really fly compared to MongoDB because it had a lot of other things like full text search, but that's not the case anymore. MongoDB is getting a lot of other features, making that less important. The Amazon services, I use the S3 service for huge amounts of data. I manage the digital archive for the Dutch Theatre Institute, and we offset everything into an Amazon S3 server. Very fast. For our purposes, it's not the fastest thing out there. Amazon has faster things again. I put Google is all over the place on here because Dremel and BigQuery doesn't replace the Hadoop type things. It's about a decade later. Hypertable. Hypertable I put on there as something to explore. Again, it's another thing you have a need for, but the nice thing is you can explore it on a single computer for what you're trying to do. And then, where's the other one I want to say in here? I think the last one that I care before I leave is yeah, there's a lot of stuff out there for the Hadoop stuff. But again, these are things you have to have a lot of resources for to try. Something I've also used is MySQL in the clouds on steroids. It's actually Google Big Cloud, Google Cloud SQL. So there's other ways to get sort of bigger. The thing with that is you're still not doing any more than what the relational database can do. It's just you have a lot more behind you on that. I've been told, I think, that I have to stop. Hey, there's my 42 minutes. All right. I didn't get as far with things like the key value storage options and things like that and the other things here. So I'm around all night for people that want to keep talking. I'm not going to go over the entire list here. I think I'm going to get kicked out now. So, yeah. So I'm going to end it. I apologize. I got about 2/3 through. There was some beautiful samples that I knew I wouldn't get to, but I thought I'd put more in than I could. I hope people got some things out of it, and I'll post this online, or it'll be somewhere. And I think that's it. Did anyone get anything out of that? And there's my shameless plug at the end.